Hello, this is Dr. Martell, and in this brief lecture, I just want to go over the homework for week one. Mostly, this is going to be a matter of showing you what the correct answers are, or better, showing you correct answers to the problems that you've been presented with, where for most of these problems, there's more than just like one correct answer. And that's actually going to usually be the case in this course. For most of the homework, if the homework exercise presents you with a problem, there's more than one way of correctly solving the problem. This is especially true for proofs. Okay, if you're dealing with if you're dealing with a valid argument, there are actually any number of ways of correctly constructing a proof going from the premises to the conclusion. Right? So when I go over homework, I'm going to be showing you at least one of the correct answers among, in some cases, any number of correct answers. So I'm going to go ahead and begin, of course, with exercises 1.2 and 1.3. Okay, so you're supposed to do these exercises within Tarski's world. And 1.2, that was just a matter of reproducing the sentences that appear in the book on the right-hand side of the Tarski's world window, where, of course, the sentences belong. You could either just manually type everything in. I don't recommend that because it's time-consuming and there's more possibility for user error. You could also use the buttons that are provided to just select a few of them and create the needed sentences. So for 1.3, what you needed to do is you needed to create a world on the left-hand side of the Tarski's world window that made all of the sentences on the right side from 1.2 true at the same time. Okay. When sentences can be true all at the same time, or we could also say under the same conditions, they're said to be logically consistent with one another. Okay. So what 1.3 is asking you to do is basically create a world illustrating at least one way in which all of these sentences can be true under the same conditions, and thus illustrating, actually demonstrating that the sentences are logically consistent with one another. Okay. As most of you know by now, when you start out with a blank, it's like a chessboard, right? In Tarski's world on the left-hand side of the screen, the way to populate that is to use that button that's in the upper left-hand corner that has various shapes on it and a down arrow. If you click on that, it's going to initially bring down, I think, a medium-sized cube that is unnamed, right? And then you can go ahead and change the size, change the shape, and name it if you wish. So as I indicated, there are a number of different ways of correctly solving problems that the homework exercises present you with. I have here on the left side of the Tarski's world window for this slide on exercises 1.2 and 1.3, one way of constructing a world so as to make all of those sentences on the right side of the Tarski's world window true. Okay, this is one way among others. Note too, it may be a little bit difficult to see what I've done in constructing that world from this angle. Okay, so basically looking at that world like almost head on, sort of head on and slightly above, right? Sometimes it helps in order to see what you're doing to look at the world you're constructing from a different perspective. And a way to do that is to press that button that's between those two arrows. One arrow looks like it's kind of going counterclockwise, and the other arrow looks like it's going clockwise. Okay, there's a button in between them. This is up on the right-hand corner of the world part of the Tarski's World window. There are those two arrows. In between, there's a button. That button will take you to an overview, which is sometimes nice to adopt, just to be clear on like what you're doing so far. And if you go to the next slide, I show you what results if you click that top view button. Okay, if you click it again, you'll come back to, of course, the original view. Okay, let's then go to exercise 1.4. Okay, so I want to note a couple of things that give people some problems when taking sentences that are in English and translating them into FOL. One problem is this. Standardly in English, the predicate expression comes after the subject expression. If the subject is a name, then the predicate expression, right, comes after the name. Okay. For the most part in FOL, the predicate is prefixed. Okay. The name of the object that that predicate is true of, or the names of the objects that that predicate is true of, come afterwards. Okay, so this takes a little while to kind of get the hang of. It takes a little while for this not to feel just weird and wrong. For the most part, right, predicate expressions appear first. They're prefix expressions. We do have some infix expressions, but they're sort of the exception that proves the rule about predicates. Predicates, for the most part, in this version of FOL, are prefix expressions. Okay. An infix expression, that's an expression that's going to appear between, set, right, fixed in between the names of the objects is supposed to be true of. Okay, and the best example of this is the identity relation, right, which is represented by that equal sign. Another thing that requires some getting used to, okay, where the predicate is pretty obviously what in ordinary English would be called a relation between, let's say, a couple of different objects, like smaller, right? That's pretty clearly a predicate. It tells you about a relationship between two things. When you encounter that kind of expression in English, and you want to translate it into FOL, you're again going to have to take the predicate and almost always make it the prefix of a well-formed formula in FOL. Okay, if it's a relation between two objects like smaller, right, you're then going to, after the predicate in FOL, right, in parentheses, put first the name of one object and then the name of the other. Okay. The first object you name should be the one that appears before the predicate expression in English. So, I mean, if you started out as in our text with, in English, B is smaller than A, okay, you're going to select as your predicate in FOL smaller, okay, and then in parentheses, two names are going to occur. The first one should be the thing that's smaller than the second, okay? In this case, that's B. So the correct way to translate into English from English into FOL. 2 is, as I have here in the slide for 1.4, smaller b a. Okay. Right. And I think that's all I want to say about 1.4. Okay, I have here again, actually there's one more thing. I have here again on the left-hand side of the Tarski's world window, one world from among others that makes all of those sentences on the left-hand side of the Tarski's world window true at the same time, thus demonstrating that those statements are logically consistent statements. On to 1.5. So a number of people had some difficulty with 1.5 insofar as the grading service gave them some strange feedback. Basically, some of you submitted not just a World 1.5 file, but also, I believe, like a Sentences 1.5 file. Yeah, the grading service was not expecting that, because actually all you're supposed to do in the case of exercise or homework problem 1.5 is to work with a set of sentences called Lestrade's sentences, okay, and then, right, take a given world, world 1.5, and name previously unnamed objects in such a way as to show that Lestrade's sentences are logically consistent, right? So name the objects in this given world where nothing's been named in such a way as to make all of Lestrade's sentences simultaneously true. Okay. Again, there's more than one way of doing this. In fact, if you looked at exercise 1.6, it prompts you, having done this one way, do it another way. What I have here, though, in the slide for 1.5, right, is the way that I initially did this when going over this homework exercise myself. Okay. Your world 1.5 may have been different than mine. It could also be correct. Oh, by the way, there's a way to figure out if you are doing these exercises correctly, right, before you submit them to the grading service. So what we were asked to do here was to name hitherto unnamed objects in such a way as to make all the sentences among Lestrade's sentences true at once. Okay, you can check your work before submitting it to the grading service by just clicking on those buttons that appear above the sentences at the very top. Those middle 3 buttons especially are important. The TF button, that will allow you to check an individual sentence that you have clicked next to. The TF button in the middle of those 3, that will, if you click on it, immediately show the truth values of all the sentences you've got on that side of the window relative to the world that you've constructed on the left-hand side of the window. Okay, so it's often a good idea before submitting to the grading service, right, to check and see, right, how things stand with those sentences that you're working with relative to the world that you've constructed. Okay, so that brings me to the most troubling exercise, homework exercise for this week, and that was exercise 1.9. Okay, here you didn't have to construct a world at all. What you had to do instead was, I think actually by hand, type in FOL translations of some sentences given in the textbook in English. You were given those sentences in English, and you were also given, for purposes of that exercise, a bunch of FOL terms, predicates, and names too. The names in this case, unlike the names in the exercises I've been talking about so far, and unlike actually most of the names that we'll be using in the course from this point on, the names in this case are very much like the names that you're translating from. Okay, so to translate Claire, right, with a capital C, we have in FOL Claire with a lowercase c, and the same goes for Folly. So that may have been a little bit confusing. In addition to names, you're in FOL, you're also given a number of predicates to work with. Actually, a limited number of predicates, and this is important, especially for the translation of sentence 5 in this exercise. Okay, so you're given a limited number of predicates with which to work. You're also told in every case what the arity of the predicate is. Okay, the arity of a predicate has to do with how many individual constants, named things, it takes. Okay, a unary predicate takes just one, and indeed must take one in order for the resulting expression to be well formed. Okay, a binary predicate takes two. So a unary predicate would be like, what do I have here? Well, for 1.9 is a student, right? That's a unary predicate. To form a well-formed expression using that predicate, you have to have one name appearing in parentheses after student. It's a unary predicate. There are also binary predicates. A binary predicate is going to have to take, in addition to the predicate, two names, two individual constants, in order to count as like a well-formed formula. And looking at the exercise, case in point would be earlier than. Okay, the FOL predicate, translating the English expression earlier than, is that less than symbol. Okay, if you're going to form a well-formed formula operating with that less than symbol, you need to have, in addition to the less than symbol, two names. Okay, and in this case, the less than symbol is infix, not prefix. So it should go between the names rather than in front of the names followed by parentheses. All right. Some predicates, in order to use them to form a well-formed formula, you actually have to have three names. Okay, and those are called ternary predicates. And actually, for this exercise, you're even required to use a predicate, gave, that requires four names following it in order to construct a well-formed formula. Okay. So I have in the slide for 1.9 on the on the right-hand side of the Tarski's World window, the correct FOL translations of the given English expressions. The one that caused people the most problems is 5. And that's because the sentence that you're originally given in English is a sentence that doesn't actually use the word owned at all. It instead uses the word, or phrase rather, belonged to. Okay. So what you're required to do in this case is not like just sort of invent a predicate of your own, right? And use it in the translation into FOL. You were supposed to instead figure out a way of using the given FOL predicates to accurately translate this English sentence that involves the phrase belonged to, right? The key to doing this correctly is to realize that owned is if not like the inverse of belonged to, right, or belonged to, right, at least very much like the inverse of belonged to, right? So that if A belonged to B, right, it must be the case that B owns A, right? Saying that B owns A, right, is sort of another way of saying A belongs to B, right? After all, right, these two claims, they're going to be true under the same conditions. Any world that makes A belongs to B true is going to also make B owns A true. Okay, so that was the key thing that you had to realize in order to get the correct translation for that given English sentence. So last thing I want to do in this brief presentation is to make a little bit more clear, like why it is that we're bothering to translate English sentences into FOL in the first place. I perhaps haven't been as clear about this up to now as I should have. So FOL, first order logic, that's an artificial language that captures logically relevant aspects of natural languages such as English. Logically relevant aspects of a natural language are aspects that matter for logical consequence. Okay, or in other words, they matter for whether the argument in the natural language, English, is valid or not. Okay, so when we take English sentences and translated them into FOL, what we're really doing is we're emphasizing, right, features of the natural language English that matter for whether the original English argument is valid or not. These are features that matter for whether the conclusion of that argument is a logical consequence of the premises. Okay. We're then going to develop techniques for establishing that the argument translated into FOL is valid. Okay. We'll also have some techniques, kind of informal ones, for establishing that the argument in FOL is invalid. Okay. In any case, if we can show that the translated argument, the argument that's in FOL, is valid, that shows us that the original English argument was also valid. Okay. After all, right, everything that matters, right? Well, much of what matters from a logical point of view about that original English argument, it's captured in the FOL representation. Okay? And so if I can show that the FOL representation, right, is valid, right, I will have thereby shown that the original English argument that it represents, right, it had to be valid too. After all, the original English argument and the FOL translation, they share the same logically relevant features. They share the same features that matter for whether the argument is good because valid or not. Okay, so that's some of the rationale anyway for taking the trouble to learn how to translate sentences of a natural language into FOL, and then apply these actually rather sophisticated techniques for establishing whether arguments in FOL are valid or not. And that'll do it for this time. Going forward, we're probably going to have actually many more video presentations of this kind. My plan at this point is to generally make them available by Tuesday. That gives me time to go through all of the homework and I figure out what I need to draw attention to. And it also, right, gives you enough time in the rest of the week to get a handle on what might have been going wrong the previous week, correct it, and move forward. So hopefully that's what this lecture has enabled some of you to do, especially those of you who had some difficulty, right, with various exercises, especially 1.9. And that is it for now.